Alrighty, in this video, we are going to be talking about what happens whenever u-substitution doesn't work in terms of us having something like 10, 11, and 12. So looking at number 10 here, notice how we have a numerator that has an exponent of 3 and a denominator that has an exponent of 1. If I were to have u to be x plus 5, that means that du is going to be 1. If I have u to be x cubed minus 6x minus 20, du is going to be 3x squared minus 6. And I can't find this because then that doesn't cancel out with this. And this right here doesn't cancel out with this right here. So instead, what we're going to have to do is either use long division or synthetic. In this case, for number 10, I'm going to use synthetic because I think it's a little bit easier, because your denominator is a linear function. So then I have 1, 0, negative 6, and negative 20. Make sure that you have a placeholder for x squared, and then use synthetic division. Once you get your answer, remember that this isn't your final answer. This is just me simplifying this expression right here. I'm simplifying the integral. So now, once I do that, I'm going to have the integral from x squared minus 5x plus 19 minus 115 over x plus 5 dx. This is going to be a little bit easier now because I could just integrate term by term. So then this is going to give me 1/3 x cubed minus 5/2 x squared plus 19x minus 115 ln of x plus 5 plus c. Make sure that your x plus 5 is an absolute value bars, because x plus 5 can be negative and it can be positive. So that's that. All right, on number 11, we have the integral from 0 to 1 of x minus 1 over x plus 1. Now, this one you can use u-sub in terms of you having to rewrite x in terms of u. So then remember that this would have been u minus 1, and then put that in terms of that right there. But for this one right here, what I'm going to do is use, once again, synthetic, just so that we could see what's happening here. So here, this is the same thing as saying the integral from 0 to 1 of 1 minus, well, not minus, yeah, minus 2 over x plus 1 dx. So then if we take the integral of that, that's just going to be x minus 2 ln of x plus 1. And honestly, since we are going from 0 to 1, I'm not going to include my absolute value bars, just because from 0 to 1, it's going to be positive anyways. So then if I were to plug in 1, I'm going to get 1 minus 2 ln of 2. If I were to plug in 0, I'm going to get 0 minus 2 ln of 1. We know that ln of 1 is 0, so my answer is just 1 minus 2 ln of 2. Or you might see 1 minus ln of 4. Number 10 and 11 used synthetic, but number 12 here, sometimes you won't be able to use synthetic and you might have to use long division. So for number 12, we're going to be using good old long division. All right. So that is going to give me 1 right here, x squared plus 1. And then if I were to subtract that, that's just going to give me an x. Well, x doesn't really do anything, so that I'm going to have the integral from 1 plus x over x squared plus 1 dx. This one is a little bit easier now because I could take the antiderivative of 1. That's great. And then for this part right here, I can use u-sub. So u is going to be x squared plus 1 du is going to be 2x dx. So then, if I were to use u sub, I'm going to get 1/2 1 over u du. The x's will cancel out, and then I'm going to have a 1/2 right here. Then I'm going to have, let's see, if I were to integrate this right here, I'm going to have 1/2 ln of absolute value of u plus c. We know that u is x squared plus 1, and because x squared plus 1 is always positive, I'm not going to write my absolute value bars. So that's just going to be x squared plus 1 right here. Then don't forget that the integral of 1 is just x. So my answer here would be x plus 1/2 ln of x squared plus 1 plus c. All right, we're going to do the same thing for number 13 here, where we are going to use long division. Make sure that you have placeholders for the third power, the second power, so that you don't make any silly, goofy mistakes. Okay, so then you have x squared, 2x squared. So then you get 0x to the third minus 2x squared. And then to get, let me get rid of this. To get rid of the negative 2x squared, I'm going to subtract 2. Subtract 2. So that means that I have x as my little remainder here. So then I have the integral from x squared minus 2 plus x over x squared plus 2 dx. Once again, for this term right here, what we're going to do is use u sub. Use x squared plus 2. Du use 2x dx. That's perfect because then the x's will cancel out. So then I have 1/2 1 over u du. And then that's just going to be 1/2 ln of u. Now we know that u is x squared plus 2, and once again, I'm not going to have absolute value bars just because I know that x squared plus 2 is always positive. And then don't forget to take the integral of x squared and the integral of negative 2. So this right here is my answer. All right. So at this point, looking at 14 through 19, it's just a game of, are we going to be using u sub, or do we have to use long division and synthetic division? So let's look at 14 and see what we could do here. So for number 14, I have the integral of x times x minus 2 over x minus 1 to the third power. Now, I can't really use long division or synthetic division because my denominator has a higher degree. So at this point, the only option that we have is using u sub, which means that u is going to be x minus 1, and then du is just going to be 1 dx. Well, here's my problem. If I have u to be x minus 1, I'm going to have the integral from the integral of x minus 2, and then u to the third power du. Can't cancel out any of the x's, so what I'm going to have to do in terms of this right here is go ahead and rewrite x so that it is in terms of u, like we did in the last unit. So x in terms of u is going to be u plus 1. So then I'm going to have the integral of u plus 1 times u plus 1 minus 2 over u to the third du. I'm going to simplify her a little bit, so that's going to be u minus 1. Huh? Now that's going to give me u squared minus 1, so now I have the integral of u squared minus 1 over u to the third power du. And at this point, what we're going to be doing is splitting this up so that I have u squared over u to the third minus 1 over u to the third du. Simplify this one, that's going to be 1 over u minus 1 over u to the third du. And then at this point, we are going to take the antiderivative of both. So let me rewrite this so that looks like that. Well, that one you don't have to because it's just going to be ln. So then we get what is that? Ln of u, and then we're going to up power and divide. So if I up my power, I'm going to get -2. Yep. Then plus c. So then our final answer here is going to be ln of whatever my u term was. And remember, u was x minus 1. So I have ln of x minus 1 plus 1/2 x minus 1 to the -2. Now remember that x minus 1 is negative and positive, so I do want to make sure that I have my absolute value bars here. Then this right here is going to be my final answer. Lots of fun. I know. All right. You should be able to do the rest, 15, 16, 17, 18, and 19. So think about, do you have to use long division? If not, then use u-sub. And if you can't use traditional u-sub, then you might have to do something like number 14, where you have to solve for x in terms of u. In the next video, we are going to be talking about exponential differentiation and integration. That one is going to be more fun.